this rough journey. I want to just take this opportunity to remind all of us, the students, that this 1 hour is ours, and you're free to share with us your progress. You're free to share with us your challenges so far, and indeed, you're free to tell us what is happening in your space, how you can help us, and how we may be able to help you. So it's very important. This journey, many people have said, it's a lonely one, but this platform gives us opportunity to be able to share with one another. So I want to say that to you and me who have decided to be part of this platform, this journey is not a lonely one, because now we have a scholarly community, and so we'll be able to share with one another what is happening. I want to really appreciate our professor, Joseph Mtai, for really thinking and coming up with an idea like this that collects all of us in this time of the night to learn. We want to thank you, Professor. Thank you very much. As students, we may not have anything really to give you, but we thank you. We thank you indeed for giving us the opportunity, 1 hour dedicated to us as students. And that's why I really want to urge us as students to really take this as a very golden opportunity for us to be able to learn a number of things and share with one another. It's very important. I also want to very much recognize other professors who are with us in this very first 1 hour. Professor James Kagari from Chambogo University, you're very welcome. Your commitment every day, you are one of those few people who never misses the students' hour. We are very grateful. Thank you very much. I have seen something on the chat. Somebody confirmed that they can hear. I've seen a message from Doris that she can't hear. Someone confirm?
Yes, yeah, I can hear very well.
Okay, thank you. I've seen a chat, and I think there's one. Okay, yeah. So that's the. I was just appreciating the effort by the senior researchers, senior scholars, and one of them is really Professor James from Chambogo, and we want to thank you. We really want to thank you indeed for your commitment to guide us and to help us move in this journey. I also want to recognize that we have Dr. Austin Mwanje. Doctor, we appreciate you. Thank you very much for being part of us this morning, and we are grateful. We pray that the good Lord blesses you and the rest of our colleagues, professors who are in here, and doctors. And if I've not seen many of the senior mentors, I think we'll be recognizing you as time goes on. There are students that never miss. I want to thank you indeed. Without you logging in, we will have nobody to speak to this morning. And so I really want to thank you. Thank you very much. Last week, we decided to take off some time and just talk about ourselves, talk about what is happening with you and what's happening with me. And we had a good time. many people were able to come up and tell us what they are doing in their space and how far they have moved. And I think that was very important. We will be doing that more often because it's very important that we give accountability. It's not good for us to wake up every Sunday morning for the whole year, and in the end, we do not know whether you're moving or you're still stuck. And so I was glad when people came up and spoke about what's happening in their space. And indeed, some people were able to get some help. Professor Bichu spoke to some of the students who were on call that morning, and I think we have somebody from Nairobi who had really a very good response from Professor Bichu. And so these are things that we are looking at. And the more we do this, the more we can be able to move. So I want to encourage you and myself that don't keep silent with what you're doing. It's better they shock you with your work now than waiting to go to the defense and then they chase you away. It's better you let your work be critiqued now so that you're able to make constructive changes and improvements so that when you reach there, you have the stamina to defend what you're doing and that you'll be able to convince the panel that this is what I'm doing and I'm sure of what I'm doing. So thank you very much. This morning, I also want to remind us that over the past 3 weeks, I think, we have been looking at data analysis and data interpretation, and Dr. Gideon has been ably handling that and taking us through. So this morning, I thought maybe for some of us who have not been attending, and maybe for one reason or the other, you could have missed some few things. I thought that we would just have a short clip, and that talks about the same. It may not necessarily be exactly what Dr. Gideon taught us, but there are some few things that you might pick from there and can help you, especially for those who are at that stage. As I keep telling ourselves that unlike other structured, I don't know how to call it, but there are certain structured levels of education, like in a secondary school or primary school, where we all start academic year together at the same time. If it's going to P7, we all go at the same time, and almost everywhere in the country, we are studying similar things. With the PhD, is a little bit different. People are joining at their own time. So today we are here with the people who are waiting to present their results. And yet there are some of us who are here and we are struggling how to craft a topic. Some of us, we are here and we are wondering which area can I be able to make my contribution in terms of research. So we are at different stages, we are at different levels, but the good thing is that we can still learn from each other. Those who have gone a little bit ahead should be able to help us who are still behind. So let's coexist. Those who are too much ahead with those who are too much behind, and those who are in the middle. Let's just coexist and see how we can help each other. So I want to just welcome you to this simple and short clip that we can watch and listen and try to pick some few things in regard to data analysis and data interpretation. And as I've already alluded to, it's just to remind us the few things that we have been taught. It may not necessarily give us exactly everything, but it can pick some few things and then we'll be able to move on. After that, we'll be able to spare some few minutes where you should be able to tell us what you could have learned or where you still have challenges, and then we discuss. So welcome with me to watch this short video.
Welcome to this full course about regression analysis. Do you finally want to understand regression analysis? Then this is the place for you. My name is Hannah and welcome to this full course about regression analysis. After watching this video, you will know what regression analysis is and what the difference is between simple and multiple linear regression are. Further, you will be able to interpret your results, understand the assumptions for a linear regression, and also the use of dummy variables. And at the end, I explain to you the basics about logistic regression. And of course, I'll also show you how to calculate a regression easily online. Let's get started. A regression analysis allows you to infer or predict a variable based on one or more other variables. Let's say you want to find out what influences the salary of people. For example, you could take the highest level of education, the weekly working hours, and the age of people. Now you can investigate whether these three variables have an influence on the salary. If you can do so, you can predict a person's salary by taking the highest educational level, the weekly working hours, and a person's age. The variable you want to infer, the one that you want to predict, is also called the dependent variable or criterion. The variables you use for your prediction are called independent variables or predictors. Regression analysis can be used to achieve two goals. First, you can measure the influence of one variable or several variables on another variable, or you can predict a variable based on other variables. This is the second goal. In order to give you a feeling for this, let's go through some examples now. Let's start by measuring the influence of one or more variables on another. In the context of your research work, you might be interested in what has an influence on children's ability to concentrate. You're interested in whether you can prove that there are parameters that positively or negatively influence children's ability to concentrate. But in this case, you're not interested in predicting children's ability to concentrate. Another example would be you could investigate whether the educational level of parents and the place of residence have an influence on the future educational level of children. This area is very research-based and has a lot of application in the social and economic sciences. The second area, which is using regressions for predictions, is more application-oriented. Let's say in order to get the most out of hospital occupancy, you might be interested in how long a patient will stay in the hospital. So based on the characteristics of the prospective patient, such as age, reason for stay, and pre-existing conditions, you want to know how long this person is likely to stay in the hospital. Based on this prediction, you can, for example, optimize bed planning. Another example would be that as an operator of an online store, you may be very interested in which product a person is most likely to buy. So you want to suggest this product to the visitor in order to increase the sales of the online store. This is where regression comes into play. What we now need to know is that there are different types of regression analysis, and we get started with these types right now. In regression analysis, a distinction is made between simple linear, multiple linear, and logistic regression. In simple linear regression, you use only one independent variable to infer the dependent variable. In the example where we want to predict the salary of people, we use only one variable, either, for example, if a person has studied or not, the weekly working hours, or the age of a person. In multiple linear regression, we use several independent variables to infer our dependent variable. So we use the highest educational level, weekly working hours, and the age of a person. So therefore, the difference between a simple and a multiple regression is that in one case we only use one independent variable, and in the other case we use several independent variables. Both cases have in common that the dependent variable is metric, and metric variables are, for example, the salary of a person, the body size, the shoe size, or, for example, the electricity consumption. In contrast to that, logistic regression is used when you have a categorical dependent variable. So, for example, when you want to infer whether a person is at high risk of burnout or not. Whenever yes and no answers are possible, you use a logistic regression. So in linear regression, the dependent variable is metric. In logistic regression, it is categorical. Whenever the dependent variable is yes or no, you will use a logistic regression. Does one person buy a product, yes or no? Is a person healthy or sick? Does a person vote for a certain party, yes or no? And so on and so forth. In all these cases, it does not matter what scale level the independent variables have. They can be either nominal, ordinal, or metric. So as I just said, the scale level of the dependent variable can be metric, ordinal, or nominal in all three cases. So in the simple linear, in the multiple linear, and in a logistic regression. The dependent variable is metric in the linear case, and it is nominal or ordinal in the case of a logistic regression. It is important to know that in the case of a nominal or an ordinal independent variable, the variables may classically have only two characteristics, such as gender with male and female. If your variables have more than two characteristics, then you have to form so-called dummy variables. But we will talk about dummy variables a bit later. So now a quick recap for you. There is the simple linear regression, and the question could be, does the weekly working time have an impact on the hourly wage of people? The distinguishing point is that we have only one independent variable in this case. Then there is the multiple linear regression. A question could be, do the weekly working hours and the age of employees have an influence on the hourly wage? In this case, we have at least two independent variables, so for example, weekly working hours and age. And now let's look at the last case, which is logistic regression. Here the question could be, do the weekly working hours and the age of employees have an influence on the probability that they are at risk of burnout? In this case, burnout at risk has the expressions yes or no. So now I hope you got a first impression about what regression analysis is, and we'll move on to the linear regression now. Let's get started. As you already know, a regression analysis allows you to infer or predict a variable based on one or more other variables. But what is the difference between a simple linear regression and a multiple linear regression? Let's first start with the simple linear regression. The goal of a simple linear regression is to predict the value of a dependent variable based on an independent variable. The greater the linear relationship between the independent variable and the dependent variable is, the more accurate is the prediction. Visually, the relationship between the variables can be represented in a scatter plot. The greater the linear relationship between the dependent and the independent variable, the more the data points lie on a straight line. The task of a simple linear regression is now to determine exactly the straight line that best describes the relationship between the dependent and the independent variable. In the context of a linear regression analysis, a straight line is plotted on the scatter plot. In order to determine the straight line, the linear regression uses the method of least squares. Let's say a hospital asks you to give them an estimate based on the age of a person, how long this person will stay in the hospital after a surgery. The target of the hospital operator is to optimize the bed planning. In this example, your dependent variable, the one you want to infer, is the length of stay after surgery. Your independent variable is the age of a person. The equation that describes the model now looks like this. B is the slope and A is the receptor point. If a person would be 0 years old, which doesn't really make sense in this example, the model would tell us that this person stays 8 days in the hospital. In order to calculate the coefficients, the hospital must of course provide you with a sample of people where you know the age and the length of stay after surgery. By using your data, you could find out that B is 0.14 and A is 1.2. This is now our model, which helps us to estimate the length of stay after surgery based on the age of people. Now let's say a person who is 33 years old is registered for a surgery. Then we would put 33 for X. Our model then tells us that this person stays in the hospital for 5.82 days after surgery. Now, of course, the question is, how do you calculate the slope B and how do you calculate the intercept A? Usually, you use a statistics program like DataTab. In the case of simple linear regression, however, it is also quite simple to do this by hand. B results from the correlation of the two variables times the standard deviation of the variable length of stay after surgery divided by the standard deviation of age. A is obtained by calculating the mean value of the length of stay minus the slope times the mean value of the age. The regression line always tries to map the given data with a straight line as best as possible. Of course, this always results in an error. This error is called epsilon. Let's say we estimate the length of stay after surgery of a person who is 33 years old. Our model tells us that the person stays in the hospital for 5.82 days, but in fact, he or she stays in the hospital for 7 days. Then the difference between the estimated value and the true value is our error, and exactly the error epsilon. Now you have a good overview of what a simple linear regression is, and we proceed with the multiple linear regression now. Unlike simple linear regression, multiple linear regression allows for the consideration of more than 2 independent variables. As we already know, the goal of a regression is to estimate one variable based on several other variables. The variable to be estimated is called the dependent variable or criterion. The variables that are used for prediction are called independent variables or predictors. Multiple linear regression can be used to control for the influence of a third-party variable. Multiple linear regression is often used in empirical social research as well as in market research. In both areas, it is of interest to find out what influence different factors have on a certain variable. Therefore, the equation for a simple linear regression looks like this. We have one independent variable x plus the constant. If we now go the way of multiple linear regression, we have several independent variables. The first variable, the second variable, and the kth variable. The coefficients can now be interpreted similarly to the linear regression equation. If all independent variables are 0, we get the value a. If an independent variable changes by 1 unit, the corresponding coefficient b indicates by how much the dependent variable changes. Let's say x1 is the age of a person and b1 is 10. Then for every further year, y is increased by 10. If the person is 5, we have 5 times 10, which equals 50. So y is increased by 50. Before we now look at the interpretation of the regression results, I will first explain to you how you can easily calculate a linear regression online. In order to do this, simply visit Data tab. You can find the link in the video description and just copy your own data into this table. Then you simply click on the Regression tab. After you've copied your data into the upper table, your variables will appear here below. Now you only need to select your dependent variable and one or more independent variables. Of course, this dataset is far too small, but it just serves us as an example. Your own dataset may of course have several thousand rows. Let's say we want to find out what influences a person's salary, so we choose salary as the dependent variable. As the independent variables, we can now choose gender, age, and for example, weight. As soon as you've selected the variables you want to use, Data tab calculates a regression analysis for you. Since your dependent variable has a matrix scale level, a linear regression is calculated. Now you can see the results here. We will go through the interpretation of the results in detail in a moment. The good thing is the Data tab also helps you with the interpretation. So just click here. A multiple linear regression analysis was performed to examine whether male, age, or weight variables significantly predict salary. The regression model indicated that the predictors explained 48.99% of the variance, and a collective significant effect was not found. F equals 2.56, P equals 0.1, and R squared is 0.49. But let's now go into more detail about the interpretation of results. Your results will be presented to you in this form. You can now, of course, just use the interpretation in words on Data tab, but we'll go through each block individually. Let's start with the model summary. The multiple correlation coefficient R measures the correlation between the dependent variable and the combination of the independent variables. What does that mean? Here we see the equation for linear regression. Our statistics program, like Data tab, calculates the regression coefficients. Now you can sum up all the values, and with the summed values you can calculate the correlation with the dependent variable. This correlation is the multiple correlation coefficient R. Or to say it in other words, with the regression coefficients and the independent variables, an estimate of the dependent variable is calculated. R now indicates how strong the correlation is between the true dependent variable and the estimated variable. Therefore, the greater the correlation, the better the regression model. The coefficient of determination R squared indicates how much the variance of the dependent variable can be explained by the independent variables. Your dependent variable has a certain variance. The more of this variance we can explain, the better it is. Let's take the example of how long you stay in the hospital after surgery. Of course, not every person stays in the hospital for the same amount of time, so we have a variation, and it's this variation that we want to explain with the help of a regression model. If, for example, we can predict the length of stay in hospital very well with the age and the type of surgery, this R squared is very large. If we can even explain everything, the result would be 1. In this case, we could predict exactly how long a person will stay in the hospital after a surgery using only the age and the type of operation, and we can explain all the variance of the dependent variable. But of course, that doesn't happen very often in practice. R squared overestimates the coefficients of determination when too many independent variables are used. To fix this issue, the adjusted R square is often calculated. The standard estimation error indicates by how much the model overestimates the dependent variable on average. Let's say you want to predict the length of stay in days after surgery. If your standard estimation error, for example, is 4, this would mean that you miscalculate on average by 4 days with your prediction. Now, of course, your question to the hospital management would be whether an average deviation of 4 days is too much, or whether the hospital says, great, this enables us a much better planning security. So next, this table is displayed. Here, the so-called F-test is calculated. The F-test tests the null hypothesis whether the variance explanation R squared in the population is 0. This test is often not of great interest. The test is equivalent to asserting that all true slope coefficients in the population are 0. So B1 is 0, B2 is 0, and up to Bk is 0. In this case, since we have a very small data set in our example, the results show that the null hypothesis cannot be rejected. The p-value is greater than 0.05, and we assume, based on available data, that all coefficients are 0. So now we reach the probably most interesting table. Here we see the unstandardized coefficients, the standardized coefficients, and the significance level. Capital B, the unstandardized coefficients, are just the coefficients that you can put into your regression equation. So if we want to predict the salary, we have a constant of 1920, plus the value of the gender variable, plus the value for the age variable, plus weight. This allows us to use the unstandardized regression coefficients to build our regression model. If we want to predict the salary, we now only have to insert the variables. Beta are the standardized coefficients. Here you can see which variable has the greatest influence on the salary. In this case, age has the greatest influence on salary because beta of age has the greatest amount. And finally, we see the significance value for the coefficients. Values smaller than 0.05 are considered significant. In this case, we see that not a single coefficient is significant. What does that mean now? The null hypothesis in each case is that these coefficients are 0 in the population. If the p-value is greater than 0.05, we cannot reject this null hypothesis based on the available data. And thus, it is assumed that the coefficients in the population are not different from 0, and therefore the variables have no influence on salary. Due to the fact that I've used a data set that is actually very small, it's difficult to reach significant values. Of course, when calculating a regression analysis, you also have to check the assumptions. If the assumptions are not fulfilled, you cannot interpret the results of the regression meaningfully. Therefore, we now take a look at the assumptions. The assumptions for the linear regression are as follows. There must be a linear relationship between the error epsilon must be normally distributed. Third assumption is that there must be no multicollinearity or no instability of the regression coefficients. And finally, there must not be heteroscedasticity. The variance of the residuals must be constant over the predicted values. And now we'll go into each point in more detail. Let's get started. In a linear regression, a straight line is drawn through the data. This straight line should represent all points as good as possible. If the points are non-linear, the straight line cannot fulfill this task. Let's look at these two graphs. In the first one, we see a nice linear relationship between the dependent and the independent variable. Here, the regression line can be drawn in a meaningful way. In the second case, however, we see that there is a clearly non-linear relationship between the dependent and the independent variable. Therefore, it's not possible to put the regression line meaningfully through the points. Since this is not possible, the coefficients of the regression model cannot be interpreted meaningfully, or errors in the prediction can occur that are larger than expected. Therefore, we have to check at the beginning whether there is a linear relationship between the dependent and the independent variables. This is usually done graphically. The next requirement is that the error epsilon must be normally distributed. In order to check this, there are two ways. One is the analytical way and the other one is the graphical way. When using the analytical way, you can use either the Kolmogorov-Smirnov test or the Shapiro-Wilk test. If the p-value is greater than 0.05, there is no deviation of the data from the normal distribution, so it can be assumed that your data are normally distributed. However, these analytical tests are not used that often anymore because they tend to always attest normal distribution in small samples, and they become significant very quickly in larger samples, thus rejecting the null hypothesis that the data is normally distributed. Therefore, the graphical version is used more and more. For the graphical solution, you can either look at the histogram or better, the QQ plot. The more your data lies on the line, the better is the normal distribution. And now we come to the heteroscedasticity. Another assumption for the linear regression is that the residuals have a constant variance. Since your regression model never exactly predicts your dependent variable in practice, you always have a certain error. Now you can plot your dependent variable on the x-axis and the error on the y-axis. The error should scatter evenly over the whole range. Then homoscedasticity is present. However, if the results look like this, then we have heteroscedasticity. In this case, we have different error variances depending on the value range of the dependent variable. This should not be the case. And before I show you how you can check the assumptions online, we now come to the last assumption, which is no multicollinearity. Multicollinearity means that two or more independent variables are strongly correlated with each other. The problem with multicollinearity is that the effect of individual variables cannot be clearly separated. Let's look at the regression equation again. There we have the dependent variable and here the independent variables with the respective coefficients. So now, for example, if there is a high correlation between x1 and x2, or if these two variables are almost equal, then it is difficult to determine B1 and B2. If both are completely equal, the regression model does not know what B1 and B2 should be. This means that the regression model becomes unstable. If you want to use the regression model for a prediction, it does not matter whether there is multicollinearity or not. In a prediction, you're only interested in how good the prediction is, but you're not interested in how big the influence of the respective variables is. However, if the regression model is used to measure the influence of the independent variable on the dependent variable, there must not be multicollinearity. And if there is, the coefficients cannot be interpreted meaningfully. So now the question is, how can we diagnose multicollinearity? If we look at the regression equation again, we have the variables x1, x2, up to the variable xk. We now want to know if x1 is quite identical to another variable or a combination of the other variables. In order to do this, we simply set up a new regression model. In this new regression model, we take x1 as the new dependent variable. If we can now predict x1 very well by using the other independent variables, we don't need x1 anymore because we can use the other variables instead. If we would now use all variables, It could be that the regression model is unstable. In mathematics, we say that the equation is overdetermined. We can now do this for all other variables. So we estimate now x2 by using the other independent variables, and we estimate xk by using the other independent variables. For all k regressions, in this case we have k new regression models, we calculate the so-called tolerance or the VIF value. The tolerance is obtained by taking 1 minus r squared, which is the variance explanation. Once again, the variance explanation indicates how much of the variance of x1 can be explained by the other variables. The more it is, the more one speaks of multicollinearity. If these variables can explain 100% of the variance of x1, then we no longer need x1 in the upper equation. If the tolerance is less than 0.1, you have to be careful, because in this case we could have multicollinearity. On the other hand, we have the VIF value. The VIF value is calculated by dividing 1 by the tolerance. Accordingly, you have to be careful if the values are greater than 10. And now I will show you how you can test the assumptions online. If you want to test the assumptions online with DataTab, you only need to select your variables and then click on Check Assumptions. Now you see a nice overview of the results here. You can check the linearity, the normal distribution of the error, the multicollinearity, and the heteroscedasticity. It's very simple, just try it yourself. Now it's time to look at dummy variables. You have to use dummy variables if you want to use categorical variables with more than 2 values as your independent variables. As independent variables or predictors, either metric or categorical variables with 2 expressions can be used. Of course, it's also possible to use variables with more than 2 categories, and I will explain this to you in the next slides. Categorical variables with 2 characteristics are also called dichotomous. An example would be gender with the categories male and female. Let's say you coded female as 0 and male as 1. In this case, female would be the reference category. If we now look at the regression equation and say the variable x1 is gender, then b1 is the regression coefficient for gender. Now how can we interpret b1? We said 0 is female and 1 is male, so we just put that in. Then we have 0 times b1 for a female person and 1 times b1 for a male person. Accordingly, b1 indicates the difference between male and female. Let's say we want to predict the income of a person, so y is the income. If a person is male, this person earns more by the amount of b1 than a woman. If the person is male, there is a 1 here and we have 1 times this value. If the person is female, there is a 0 here and we have 0 times this value. If b1 is 400, for example, then it means that men earn 400 euros more than women according to this model. Now we've discussed how to handle variables with 2 values. Further, we should look at what we do when we have a variable with more than 2 values or categories. Let's say you want to predict the fuel consumption of a car based on its horsepower and the vehicle type. And let's say there are only 3 vehicle types: sedan, sports car and family van. Thus, here we have a variable vehicle type with more than 2 characteristics, but for a regression model, we need a categorical variable with 2 characteristics. Therefore, the question is now, what should we do next? In order to use categorical variables in a regression, we have to create dummy variables. This means that we simply create 3 new variables. Each new variable has 2 characteristics. These characteristics are 0 and 1, or yes or no. So here we have our vehicle type with the characteristics sedan, sports car and family van. Now we create 1 new variable for each characteristic. So first we create the variable, is it a sedan, yes or no. Second would be, is it a sports car, yes or no. And our third variable asks, is it a family van, yes or no. So before we had 1 variable and now we got 3 variables which are dichotomous, and therefore they all have only 2 characteristics. And these 3 new variables can now be used in the regression model. So the next question is now, what does that mean for the data preparation? You originally have 1 column with the vehicle type where the individual vehicles from your sample are listed. The first is a sedan, the second is also a sedan, the third is a sports car, and so on and so forth. Out of this table, you create your 3 new variables. What is the first car? A sedan, so you put a 1 here and a 0 for the others. It's not a sports car and it's not a family van. The second one is also a sedan, so we'll put a 1 here again. And the third one is a sports car, so we'll put a 1 here and the others are 0. By continuing this procedure, we have finally created our new dummy variables. Now there's only one important thing to note. The number of dummy variables is always the number of characteristics minus 1. Why is that the case? If we know that it is a sedan, we are sure that it's not a family van. If we know that it is a sports car, we can also be sure that it's not a family van. And if it's not a sedan and not a sports car, we can be sure that it is a family van. Accordingly, one of the 3 variables is not needed because this information is redundant. Therefore, n-1 dummy variables are created. So in this case, we only need the dummy variable, is it a sedan or is it a sports car? Of course, you can also drop sedan and use the other 2. And now I'll show you how you can create the dummy variables online with Data tab. In this example, we use salary as our dependent variable and as independent variable the age and the company. The variable company here has 3 characteristics, BMW, Ford and GM. Now we can see that Data tab automatically creates the dummy variables. Once we have the age and once the new dummy variables, is it BMW and is it Ford? Since we only need n-1 dummy variables, the last category was dropped. If your dependent variable is categorical, then you need the logistic regression. And logistic regression is what we are going to look at now. In the previous part, we discussed linear regression. In a linear regression, the dependent variable is metric. For example, it could be salary or height. Now let's look at the logistic regression. Here the dependent variable is a categorical variable. Let's say you want to predict whether a person is at risk for burnout or not. You want to make this prediction by asking a person's highest educational attainment, weekly working hours, and a person's age. Since the variable whether a person is at risk for burnout or not is a categorical variable, you have to use a logistic regression. The logistic regression is a special case of regression analysis, and it is calculated when the dependent variable is nominally or ordinally scaled. Let's look at a few examples first. For an online retailer, you need to predict which product a particular customer is most likely to buy. In order to do this, you receive a data set with past visitors and their purchases from the online retailer. In this case, you need a logistic regression because your dependent variable is a categorical variable, namely which product is a particular customer most likely to buy. The second example comes from the medical area. You want to investigate whether a person is susceptible to a certain disease or not. For this purpose, you receive a data set with deceased and non-deceased people, as well as other medical parameters. Again, in this case, you need a logistic regression because a dependent variable is categorical and it asks, is a particular disease or not? And the last example comes from politics. The question could be, would a person vote for party A if there were elections next weekend? So again, a categorical dependent variable with yes and no as response options. What is logistic regression now? In a basic form of logistic regression, dichotomous variables, that is, variables with the characteristics 0 and 1, or yes or no, can be predicted. For this purpose, the probability of occurrence of characteristic 1, which is characteristic present, is estimated. In medicine, for example, a common goal is to find out which variables have an impact on a disease. In this case, 0 could be not deceased and 1 deceased. And the influence of age, gender, and for example, smoking status on this particular disease could be examined. Let's look at this in a graphical way. So we have our independent variables age, gender, and smoking status, and we use these three variables in order to predict whether a person is likely to get a certain disease or not. So the dependent variable is, will the person get a disease or not? So maybe now you might ask yourself the question, and why do I need a logistic regression for this? Why can't I just use a linear regression? A quick recap, in a linear regression, this is our regression equation. Now we have a dependent variable that is 0 or 1. Therefore, no matter what value we have in a dependent variables, we always get either 0 or 1. If we are using a linear regression, we would simply put a linear straight line into these points. The graph shows that values between plus and minus infinity can now occur. The goal of logistic regression is to estimate the probability of occurrence, not the value of the variable itself. So we want to know how likely it is that a value of 1 will be the result of the given values for our independent variables. The range of values for the prediction is thus restricted to the range of 0 to 1. In order to ensure that only values between 0 and 1 are possible, the logistic function is used. The logistic model is based on the logistic function. The important thing about the logistic function is that only values between 0 and 1 are possible. So no matter where we are here on the x-axis, between minus and plus infinity, we can only get values between 0 and 1 as a result. And that is exactly what we want. The equation for logistic regression now looks like this. We have 1 divided by 1 plus e to the power of minus z. For z, we now use the usual equation from the linear regression, which is the equation here below. b1 to bk are the regression coefficients, and a is the on point, x1 to xk are the independent variables. After we insert all that, our logistic function looks like this. Now we need to determine the coefficients so that our model best represents the given data. In order to solve this problem, we use the so-called maximum likelihood method. There are good numerical solutions that help us solve the problem. So usually we just use a statistics program and it will give us the values b1, b2 up to bk. Finally, I will now show you how to calculate a logistic regression online with DataTab. In order to do this, you just visit datatab.net and you copy your own data into this table. When you select a categorical dependent variable, a logistic regression is automatically calculated. Let's say your dependent variable is a person buys a product or not, with the expressions yes and no, and the independent variables are salary and age. After you click on the variables, a logistic regression is automatically calculated. And now you get the results, which you can see below. The first table is the so-called classification table. This table tells us how well we can classify the categories with the regression model. After that, we get the model summary and the coefficients. I hope you liked this video and see you next time.
Well, thank you. Thank you for watching and listening to this. As I said earlier, that these are some of the things that have already been handled by Dr. Gideon in our previous sessions, I think 2-3 weeks back. And so the purpose here was simply to remind us some of the things that we have already covered. And then number two, for those people who, for one reason or another, could have missed those sessions. So I thought we'd just go through some of these few things. Unfortunately, the time may not allow us to have discussions. I usually like after we watch such a clip, we'll be able to give people opportunity to just tell us if the video has made sense to them. But unfortunately, now we may not have that time. Maybe the other thing I wanted to, again, to re-echo is that some of the, I think we have some of the recordings that we may share. I've seen a number of people sending me direct messages asking for the previous videos. Well, I'll speak with Dr. Walugembe and probably Professor Antai and see if some of those videos can be made accessible to you for you to be able to make use of them. Now, I just want to bring this session to an end because our time seems to have run out. We just have 1 minute or so to be able to bring this session to an end. But I must thank you. Thank you very much for logging in and being part of the students' session. Again, I want to remind you that this is our time. This first 1 hour is our time. Feel free, get in touch with us if you have something you think we can share in the next 1 hour in the next coming week. Kindly let me know early, and then we'll be able to look around for some of the clips that can address that issue. And if we cannot get the clips, it gives us enough time to try to find somebody who can handle it for us. I got some calls yesterday, but was a bit late. I think it was around the 5, and so it was a bit late. So if you can get in touch with us early, it helps us in planning so that we can be able to organize something that can address your concern. Otherwise, I want to thank you very much for being part of the session, student session this morning. Allow me now take you to Professor Michael Koche to take us through the next session. Thank you very much. Professor, over to you.
Okay, thank you so much, Joseph. It has been a very nice session, and all of us can attest that I think these mornings are really very interesting. For the people who attended last Sunday, you can attest to that. For those who didn't attend, I can assure you missed something. But the good thing you're here today. And also, I see our facilitator, our presenter is in the house. Before we get started, let me begin by appreciating the leadership of the student fraternity and all the students who have been able to log in early in the morning, and also all the senior colleagues who logged in early in the morning. Allow me also appreciate all the people from all over the world who are making sure that they log in, and also our participants from within Uganda, within East Africa, and the South African region, the West African region, and also I'm sure about our participants from Asia and Europe. Before we start with this session, allow me appreciate also our mentor, Professor Joseph Ntai. Professor, thank you so much for always being there for us and making sure that we continue growing strong. And you can see that the focus is now becoming more clear and more stronger, and really there's a lot of learning taking place. Let me acknowledge Professor Sama Daramola, Professor Laura Orobia, Professor James Kagari, Dr. Gideon Nkurunziza, Dr. Ibrahim Musenze, Dr. Austin Wange, Dr. Asada Chimuli, and our very own Dr. Ahmad Walgembe. He's one of the critical people for the running of these sessions on this platform. And most times it's not easy to appreciate what goes on behind. I appreciate Dr. Ahmad, and then also, of course, our senior men, and then also the student leaders, Sylvia, Joseph, Bosco, Bernard, and many others. So I think we need to start now. And since we have our presenter there, I would like to invite him. I believe in case I've not seen any other senior colleagues, we shall still have a session where I can acknowledge them. So members, allow me invite Dr. Gideon Nkurunziza to continue with the sessions. Dr. Gideon, you can share your screen and take us through, continue with our discussion of last time. Thank you.
Thank you, Professor Michael Ketch. I'm privileged to have again another chance to share some few insights, particularly on the path analysis and mediation testing. Last time I remember we have looked at a number of sections that feed into today's topic. The previous time we looked at the recursive models and non-recursive models. Later we went ahead to look at the origin of mediation testing. Where does it come from? And from there we even looked at the debates that has been going on the way different scholars have attempted to test the mediation. So today our major attention is to look at, if we have three variables, how do you test for the mediation? Then later we shall also have a debate on how you look at mediation testing when you have more than three variables. But before that, I want to mention about the path analysis. In most cases, as a researcher, especially at PhD level, if your interest is to use quantitative approach, it is important to understand your conceptualization. It is important to know how those arrows are connected in explaining your dependent variable. At times when you don't understand how those variables are connected using different arrows, then it becomes hard even to draw or derive the mathematical model. I know we have different types of models. We have conceptual models. We also have mathematical models, analog models, depending from the field where you are coming from, as you explain. So, ladies and gentlemen, our major attention is then to understand what path analysis is. I know, as I've mentioned, when you are theorizing, I know the theory, when you theorize, you are replicating the practice out there. There must be something either that is going wrong, or it is so exciting to the extent that maybe you are taking it as opportunity for you to either provide theoretical explanation or to conceptualize what is happening. And so you have to build a system of equations. If you are coming from the field of statistics, mathematics, the natural science, I know those people enjoy mathematical equations. But for those from social science, we also enjoy the conceptual models. So it depends on how you want to develop your path models. And in this case, this path analysis, the path analysis is very, very important. There are situations where you find you have more than one response variable or one dependent variable. You find that a variable feeds into the other. And you may find that you have two independent variables. Let me use these unknown terms, x1, x2, and y. But you find that x1 leads to x2, and then x2 leads to y. What does it mean? It means that if x1 leads to x2, that means at that point, if you stop there, your x2 is an outcome variable. It's being predicted by x1. Meaning that if you now look at again another level where x2 predicts y, then you are now into some kind of modeling, and as you model, you are trying to find that at that level, you don't take that theorization light. It means you need to revisit your theory and see whether that x2 perhaps is a mediator. It can be theoretically explained as a mediator. I am aware that, again, as you go ahead and review literature, you are able to understand the missing links. You are able to understand the link between, again, those variables in your model. And so when you have got your path analysis and you have understood it in line with your conceptualization, then the question is, at analysis level, what do you need to do? There are two major options we take. One, to use multiple linear regression in understanding the relationship between those variables that you have come up with in a conceptual model. Then two, you're also able to use, for example, the structure equation modeling, particularly by deriving the measurement model. This measurement model is the one that tends to bring out the key scores for each measurement item that you have for each of the variables, to see which ones are really very important in explaining those variables. And then, of course, at that level, there's some bit of tests that you carry, the model fitness. You need to check whether the model is fitting, the measurement model is fitting. At the same time, as you theorize, it is also important that you understand the link between those global variables. And so at that level, when you have that interest of understanding deeply about the measurement models and the relationship between those variables, that is when you go in structure equation modeling. I know the debate here is supposed to be extended further because we can't capture this in today's time. It can't be enough. But today we are going to pay attention now. How do you look at multiple linear regression, especially looking at the three variables as you look at the mediation testing? Now, this is what I've been trying to explain, that when you conceptualize, your conceptualization is guided by theory, especially at the PhD level. I'm aware of those who do economics, in most cases, believe in models, but if those models have not been tested to bring some high level validity to the extent that you can replicate those results consistently to provide the practice, because we know a good theory is the one that explains practice. If we are using a model which has not really been fully tested, ideally at PhD level, it's not really very wise to go that way. But I believe we have theories that can explain the real issue that you want to address. So at that level, you need to know that your conceptualization is supposed to be well grounded with the theory. That's why even when it comes to your implications, at least you must be able to reflect on the theories you used, and somebody must be able to listen to you and hear the contribution you are trying to make to the existing theories that perhaps you try to demonstrate their views in your study. So here I'm trying to say that I think there is one of the important theory which is the theory of planned behavior. The theory of planned behavior tells us that your behavior is determined by the intention and the attitude, plus others. There's norms, there's control. There are other predictors. I've just picked some few. Now, in this way, if you look at this model, we know that based on the theory actually tells us that for us to have attitude influencing the person's behavior or individual behavior, then the intention is very critical. So intention explains why and how the attitude leads to behavior. Now, my biggest worry today is that when we are testing for mediation, at times we don't pay attention to the research design that we are using. Remember, we are talking about path analysis, and here at this level, our concern is causation. Now, we have seen that most of the studies, even when you use cross-sectional research design, they tend to test for mediation. And I know in the future, the debate may be critical. At one point, one may be questioned why you are testing for mediation when your research design does not allow you to understand the causation. If you are gathering data at a fixed point in time, how then would you simply say that your results are bringing in an aspect of causation? I think this is food for thought for us as scholars who are contributing body of knowledge. We need to see whether this data, by the time we're analyzing to see whether the mediation exists, it is important that we are dealing with the causal relationships. And the causal relationships means that we need to pay attention to the research designs. Either use experiment. The experimental research design can bring an aspect of causation. The longitudinal studies, the panel data, the time series data, that can help you to understand the causation. So we have a challenge, especially when we are using the research design that allows us to test for associations, and then we end up calling them causations. So I think it's important also to remember that as we keep discussing the mediation testing. So I have also, when I try to also revisit this theory, it's very interesting. Again, we find that norms influence intentions, and intention influence behavior. Now, that is theoretically. Now, if you have really visited this theory in that kind of context, then when you combine the two views, the first view, we see intention providing an explanation of why attitude influences behavior. Then you also see that intention also provides an explanation of why norms influence behavior. Then, what does it mean? It means that at that level, you have conceptualized. You have to come up with the conceptual model. Now, as you come up with the conceptual model, my major point at this level is that then what is your direction of relationships? And the direction of relationships now is what we are calling the path. Now, the path of this model.
Gideon, there is a request. Increase volume.
Yes, please.
I think you need to increase the volume or move closer to your device.
Okay, some seconds, please. I hope here I'm clear now.
Yes.
Okay, thank you very much. I was explaining that when you have conceptualized, then it is important to understand the relationship between those variables. And these arrows explain the path that you are going to have. And these arrows communicate a lot, especially at the point of analysis. For example, you will discover that if the theory supports that intention is a mediating variable, is an intervening variable, then it means that you have to reflect on your study objectives and see whether you captured that in the area section, particularly in background, whether you have an objective that allows you to test for the mediation. If the theory tells you that yes, it is important, that intention is an intervening variable, meaning that if it is a mediator, it can explain why these kind of relationships have to exist. So if you look at attitude has got measures, you have operationalized it with different measures. I'm just calling them MA1, MA2, but you know, here you need to now define them. And then you can have norms, then you have your behavior. But for us to have these predictor variables, attitude and norms, to influence behavior, it is important to pay attention to the intentions. And basically, this is just informed by the theory of planned behavior, if you are using theory of planned behavior. Now, as I explain this, especially for those who are doing their PhDs now, it is important to keep reflecting, to see, to understand your path model, to understand whether your objectives are well aligned with a conceptual model or with a theoretical model. And then to understand that at the point of analysis, you must be able to see whether results replicate or try to explain your model. Indeed, this also happens as you look at the conceptual model. It is important again to look at their background. Does your background also be aligned well with your conceptual model? Because this path model will actually help you to do a lot in your PhD. In other words, it is important not to ignore the arrows. As we continue, then I wanted to say that when again you look at this model here, at analysis, now that you have confirmed that the theory of planned behavior takes intention as mediator, and perhaps we have also seen that from previous studies, they have also found that there is a link between these variables. Then the next question would be, how do we turn this model into mathematical model in a way that we are able to test for mediation? Now, whenever we have got now, already when you look at these variables, we have x1, x2, attitude, norm, intention, plus behavior. These are 4 variables. Now, if we want to test whether there is a full mediation or whether there is a partial mediation between attitude and behavior being mediated by intention, then you also want to look at whether norms can influence the intention, and again the intention finally influences the behavior, meaning that it is important to also look at whether the intention mediates the relationship between the norms and behavior. Now, when you want to test that, you need to understand how you're going to do it. We have some bit of challenge. One, I am aware that you can test for the mediating role of intention on the relationship between attitude and behavior. That's the first step. Then the next step, you test for the mediating role of intention on the relationship between norms and behavior. Now, if you do it step by step, that means you have to use the idea of multiple regression modeling. And this is where now this scholar, the Baron and Ken, brought their understanding. For them, they were just looking at the mediation, looking at mediation at step level. In other words, step by step, meaning that you cannot do it simultaneously. I think that's something we need to understand. Now, when you now do it step by step, it means you as if you are partialing out. Now, you are like, perhaps if your understanding of the theorization is that these things must work concurrently or simultaneously, and then you do it step by step, you seem to have changed the earlier theorization. That's a challenge now. But once your earlier theorization tells you that yours was to look at this from different levels, you're looking at intention mediating the relationship between attitude and behavior. Then the next level is intention mediating norms, intention. In other words, intention mediating norms and behavior, and at different levels. If it is what you had theorized, which is different from taking them simultaneously, then I think that is how you can still survive. But you can see that is now mechanical. Because if in early understanding, you had a conceptual model which is behaving this way, meaning that this must work simultaneously. That is now where we have a challenge when we use Baron and Kenne's thinking. Because Baron and Kenne's thinking, their conditions, they are just basically paying attention to 3 variables. But here you can see we have 4 variables. Now, which means it is better that if you have more than 3 variables, then you need to now use the bootstrapping using structural regression modeling. And I think that is very, very important. Otherwise, when you say I used Baron and Kenne, I used the Zobair test, because with the Zobair, his argument was just upgrading the weakness, actually upgrading the Baron and Kenne by looking at their weakness. Because Baron and Kenne would just tell you that yes, mediation exists, but they could not simply tell you the indirect contribution of the mediator by looking at the indirect effect and direct effect, and again look at total effect. Once you know the indirect effect and you know the total effect, once you get the indirect effect, then divide by the total effect and express in percentage, then you're able to know the contribution which is brought by that mediator, which again Baron and Kenne was not able to address, as we shall see when you do it practically. Now, so this is just a limitation. That's why I say today our discussion will basically look at 3 variables. Then if there are more than 3, then it is important that we use models, mediation models, that allow us to test this mediation simultaneously. And I think that's why the current debate is about the bootstrapping method. Now, the bootstrapping, again, we know that Baron and Kenne, their argument, their major focus was to assume that the data must meet all the parametric assumptions, or the diagnostic tests, depending from where you're coming from. When you have secondary data, there is where we test for diagnostic tests, and when you have primary data, there are those tests we carry. And how we do it may vary. I think it's important to know that where you're coming from and what data you're talking about. How, if you have panel data, you have term series data, how do you know that this data meets parametric assumptions? If you have secondary data, how do I know that this data meets parametric assumptions? So once you have used all those kind of assumptions and they are satisfied that you have the data which is parametric, then what does it mean? It means that then if there are 3 variables, you can now use Baron and Kenny or Zober tests. I think that is the debate we need to pick here. Here I was saying that once you have that, you have a situation, you have more than 3 variables, then ideally...
excuse me?
Yes, please.
I think there's a request that you increase the volume. I don't know what the challenge is. Maybe you might have to speak louder or move closer to your device. Oh, I don't know. Thank you. Thank you.
Okay, thank you very much. I hope, sorry. I was saying that when we have more than 3 variables, it is important to know that when you have more than 3 variables, it is a limitation to somebody who's using Zober test or Baron and Ken. Why? Because Baron and Ken, Zober test considers 3 variables. If there are more than 3 and you are going to look at mediation, you do it step by step. And when you do it step by step, you seem to be diverting from original theorization, because your original theorization has been assuming that you need all the 3, these 3 predictors, that is attitude, norms, intention. That I'm calling it Y1 because I know it can be an outcome variable when you only consider X1 and X2. I think that's why I'm calling it Y1, but it is a predictor variable. Now, if you have theorized that these 3 must work together to explain behavior, and then you use a method at analysis which allows you to partial out or to do it step by step by just partialing out attitude, intention, and behavior, then next norms, intention, and behavior, that becomes actually a problem. It becomes a problem. And that's why now it is important that you have to use structural equation modeling, which actually allows you to do a test for mediation simultaneously. Because with the structural equation modeling, it will try to cover, it covers all the predictor variables themselves. And then, or even the error terms are highly considered. And that is very, very, very important. You can't ignore the power of structural modeling. I want to say that again, last time I also mentioned that one of the other challenge of Baron and Ken with Zober test again, their weakness was when you assume that data must be normally distributed, and that's when you're able to test for mediation, to come up with the predictive model. I think that is not true, because we have got softwares that consider both large samples and small samples, because they take they take into consideration the measurement errors, which again, like if you use Amos, which assumes 200 and above sample size, then I know there's smart PLS, partially square software, which can actually help you to test for mediation using structural modeling. I think when you go to that level of testing using structural modeling, it is important to remember that is the power of that approach as you analyze your data. So if you look at this model again, you realize that when you're using the regression, model your testable mediation guided by regression, multiple regression. Multiple regression sometimes does not really bring out these the errors at the same time. No, it just tells you the final error for the predictor variable. And yet, when you look at this model here, for example, you discover that these two, the attitude norms, can actually predict intention. And you can't take it that, right. And again, intention can predict behavior. So at the point of testing for mediation, it's important to consider the number of variables you are having. Before you test for the mediation, you need to consider the number of variables that you have in the model, and see whether you want to test your model, the results of the model simultaneously, or whether even the software you're going to use actually can allow you to test for mediation for the 3 variables. It is important to explore the behavior of the data. That means when if you have 3 variables and you find the data does not meet parametric assumption, but perhaps your sample size is very small, and then you would be saved by that software that considers small samples and the non-parametric. Because if you are using, for example, smart pairs, it will recycle the samples until the distribution tends to be normal. That's where the concept of bootstrapping came from. Which is different from when you're using, for example, spaces. Statistical package for social scientists. What is this assumption? The assumption that for it is actually, it assumes that you have got smaller samples, so whatever it does would just be about estimation, but doesn't resample the number of observation you have for your data, which again is a weakness there. So when you have the sample size being greater than 30, then you can use Baron and Ken. That's one. The minimum must be 30. 2, you have 3 variables. You can identify the IV. That is independent variable. The mediator, which again is also independent variable, but it's a mediating. It provides explanation of the relationship between the independent variable and dependent variable. And then the data must satisfy the assumptions of parametric or diagonist tests. So meaning that it is mandatory that once you are going to use, you have got 3 variables and you want to test for mediation, then you must test for the parametric assumption. There you cannot ignore that. And like when you are going to use smart pairs, since it assumes both parametric and non-parametric, it can do both. Then I think that is why you need to balance your approach and also the credibility of your methodology and analysis. I think it's important to look at that. So if you use Baron and Ken, you need to pay attention to these conditions. If we now want to use Baron and Ken, we need to pay attention to these assumptions. One, you ensure that the independent variable is predicted with a dependent variable, and that beta value, which beta is the marginal or the value. For example, if you look at this model here, if I look at A, I'm using A to indicate the beta value, which is the marginal parameter, which explains the change in M due to change in X. So for B is the beta value, which is the marginal parameter that explains the change in Y due to change in M. And this C prime is the beta value, which is the marginal parameter that is the change in Y due to change in X in the presence of the mediator, Whereas this C without the prime, which is not C prime, is the direct relationship. It shows direct relationship between X and Y, whereby C is the beta value, which means you are looking at that value, which is the change in Y that is brought by change in X. Remember these X and M and Y. I think from the beginning we must know that these are variables, but X represents any kind of variable that you have in a model, which is IV, and M is also that independent variable, which is a mediator, and also Y is the dependent variable. So ideally, in your conceptual model, it is very clear that you know the real values. I know this may sound to be abstract, but these are not abstract. I think when you domesticate to your work, especially for those who are doing PhD, you will understand clearly what I'm trying to say here. So these are three conditions, actually 4 conditions. The first 2, they show the direct path. For example, how X is significantly related to M, and how M is significantly related to Y. Remember, when you get a product of A and B, the beta value between the independent variable and the mediator, and the beta value between the mediator and the dependent variable, the product gives you the indirect, that shows the indirect effect. Remember, I use the indirect effect, meaning that you are talking about causation. And so the other one is where we have the third condition. You ensure that the mediator, again, the mediator predicts Y in the presence of X as well. So once that is done, then ideally you can be able to interpret the results. Now that is about testing for mediation using Barnard Kenney from the theoretical perspective. So when we do it practically, ideally we must be able to know where we are coming from and where we are going. Though I'm aware that, again, the Zobel came up with another kind of contribution basing on Barnard Kenney's thinking. They were able to also identify some kind of the percentage of contribution of the mediator. Why? They realized that for Barnard Kenney, you only stop by probing that mediation exists, but they could not tell whether it is partial, whether it is a full mediation. And I think that is where the Zobel test brought some kind of contribution beyond this. And here, I know that if you are to use this Zobel test, there is just a MediGraph which is online. You can actually download it and then use it to test for mediation. So long as there are 3 variables, it is okay. The debate is okay, and you have found that the data meets the parametric assumptions. Now, I want to say that the kind debate again, which is not for today, I want to mention it since I'm looking at the mediation testing. I want to say that whereas these people, for example, if you look at spaces, initially there was no menu that would give you the option for mediation testing directly, that gives you the indirect effect, direct effect, and total effect. Preacher and Hayes, these guys have done great work. They came up with a process macro. Process macro which you can install in SPSS, Statistical Package for Social Scientists. That process macro can do very many things. Especially at model 4, there's that, it gives you that option when you are testing for mediation. You can just use that model 4, and then you can follow the steps, and then you'll be able to really test for mediation. And it can still give also another higher power. You can test for modulated mediation, mediated modulation. All of those things can be done using even for SPSS, so long as you have installed the process macro in your software. I think that it can be done. But I'm aware that again, even if you don't go that way, for those use starter, still can be able to test for mediation. They can also be able to test for mediation. I think the previous time, Mr. Bernard Wabukala tried to illustrate how you can even test for mediation using the starter. And I'm aware that the current debate also, there are for those who have who enjoy mathematics, also they use the R programming. R programming can also help you to test for mediation. Then plus MatPLS. So all those are softwares that can help us to test for mediation. But for today, since I'm going to use Baron and Ken, I think I have hypothetical data, which I know I have not. This one just for learning purposes, which I'm going to use, and then we can now do some 2 tests. One, using Baron and Ken assumption, and then 2, using the Bell test for today. And I think maybe later, that's when we shall also be able to look at the simultaneous mediation testing. Remember, for today, my assumption that we are doing this test step by step, on assumption that my theorization is guided in that way. Otherwise, when it is simultaneous and I have more than 3, then it becomes problematic. It may end up distorting the earlier theorization. So, Chair, I hope this time the volume is fine.
Perfect.
Okay, thank you very much. Let me use now the data and we do some tests. 1, looking at Baron and Ken assumptions. Now I have this data, although as I've said, I've just made it hypothetical for the purposes of learning, for the purposes of being engaged in understanding the mediation of three variables. what is the theory behind this? The theory behind this, as I try to come up with this data hypothetically, the theory I have in mind is that the consumption, I think we all spend, but our spending depends on the disposable income. Our spending depends on disposable income. However, I'm also aware that when we spend, at times we are satisfied. The level at which we are able to spend determines again our level of satisfaction. At the same time, I know our earning can partially explain the level of satisfaction. So that's the theory I have in mind as I was trying to come up with this hypothetical. So what does it mean? Given that theoretical understanding, it means that in my view, the level of spending mediates, in my view, the level of spending provides an explanation of the relationship between the level of income and the level of satisfaction. So, meaning that the level of spending is a mediator. And I say that mediators are also independent variables. I think that's very important to note. When we say mediating variables or intervening variables, they are also independent variables. But they provide an explanation for certain relationship to exist between other two variables. So the income is also a predictor variable or independent variable, but the level of satisfaction is the dependent variable. So we can test now we can test for the mediation using Barnard-Kenney school of thought. Barnard-Kenney school of thought. Now, Barnard-Kenney school of thought, one, initially their thinking is that for you to look for mediation, one, you need to do just preliminary kind of thing analysis. You first interrogate the data and see whether actually the association exists or the relationship exists by just running the zero order correlation. If you run the zero order correlation, although they paid attention to form measure, but before you go to that, there are these preliminary thinking that do you have the association first? That gives you the ample time now to see, oh, this relationship exists. If it exists, perhaps by the time you start predicting, then it should be there. So we can use that kind of thinking by looking at the correlation just by variate between these variables now. So we have three. One, we can look at the relationship. At this moment, I don't want to go into the choice of whether to use Spearman or Pearson. I remember we had a discussion on this in depth. For those who missed, we say that you need to understand the type of data you have before you say I'm going to use Pearson, before you use Spearman. I think it's important if your data is continuous, it follows the ratio scale, then you should be able to use the Pearson. It's important to remember that when do we use Kent-Harold, when do you use Spearman? You need to understand also whether even the data meets parametric assumptions. Otherwise, if it's non-parametric and then you're using Pearson, then it becomes a problem. But for here, the assumption that we know the data meets parametric assumption, that's why I'm choosing Pearson. Then from there, I'm sure the output cannot be seen unless I share it. So we realize that now here, if you look at the p-values, the p-value, you can see the significance level is at 1%, meaning that at 99 level of confidence, we can take this association to exist between, for example, the level of spending and the satisfaction level with 0.826, and then the level of spending and income 0.942. Then with this other one also. Remember, this correlation coefficient. It can communicate a lot, especially when you look at the independent variables being correlated highly above 0.7. When you have 0.8, 0.9, there you start being suspicious. You start being suspicious that perhaps multicollinearity issues exist. Multicollinearity issues exist. For example, if you look at the level of spending and the level of income, it is at 0.942. And we said that when you are using Baron and Ken assumptions, ensure that the number of, first of all, because you are using multiple regression as linear multiple regression models assume certain assumptions. And one of them is to ensure that there is no multicollinearity. There is no multicollinearity. So those are tests you have to test to look at now. So this gives you a chance to look at that, the likely problem that you're likely to have, which is the multicollinearity issue. Now the other one again, the good news again is that you can see the relationship exists between the association exists between the dependent variable and the mediator, and also the dependent variable and the mediator, which mediator is also independent variable, but again becomes an outcome at another level. At another level in the path model, we are taking it as an outcome of the income and based on the path model, based on the theorization that we had. So given this, it helps you to answer two things. One, to give you hope that by the time you do regression, there are chances that you're likely to have those conditions being satisfied, although I'm not sure, because it's just like having many friends. But when you are sick, do those friends, all of them, feel that your sickness can influence their decision? In other words, the correlation and association, the correlation tends to look at association, but regression tends to look at some level of prediction. Yeah, in other words, regression speaks more than the correlation. So basically, I think that's what I want to say here. At the same time, I also want to mention that also depends on what data you have, whether primary data, whether secondary data. I'm emphasizing on this because the approach we use, sometimes there are tests we carry which may not be for primary data, which may actually be for secondary data. So I think that is very important, again, to remember that as we look at this. Even interpretation also of these correlations depend on the type of data, again, you have analyzed. So having looked at this, then we can now again go ahead and we look at the other we look at the other conditions. We know that the income, which is our independent variable, should significantly predict the mediating variable, which is the level of spending. So again, we can now analyze and see when we regress using linear, we have the income, which is our independent variable, and then we also have the mediating variable, which is the level of spending. And remember, this is the one that gives us our A. Remember, if you remember the path model, when you look at the path model, that is our A, which you are looking for. The beta value, the value, which is the value of the mediator that is explained by change in the income, and which is the dependent variable. So when you do this test, what happens? We can check and see. You can see that here there's actually two very high correlation, 0.94. The F statistic, which shows the model fitness, significant, and the beta value here, you can see it is unstandardized 1.129, which again you can see it is what? It is significant. Ideally, it's also another, as I look at this again, it's very important to know if those variables are defined units. That's why sometimes it's important to transform the data such that you minimize the issues of elasticities in your data. If the income is measured differently from the level of satisfaction, again, at times you do not need to use the unstandardized coefficients, where the data has not been transformed. So ideally, I think that's something at analysis, whether you have analyzed or somebody has analyzed data for you, you must be able to revisit and know whether what is done is right, or the interpretation is right. If one is measured in different units from the dependent variable, so how are we going to interpret? If you're interpreting, then you interpret in terms of unit changes in the units now that you have considered, so long as they make sense. At times you can lie using statistics, and yes, statistics does not lie, but liars can figure. Liars can lie using statistics. So I think that's something we also need to always remember. We don't need to celebrate the results. Well, here, the first assumption, in this case, we can see that it's certified, that indeed the income predicts the mediator, which is the level of spending. Then when that is done, then we can again look at the other test, and you look at the second condition. The second condition is that the mediator must significantly predict the dependent variable. And in this case, I can regress. I can set, then I regress. My dependent variable is the level of satisfaction, and my mediator is the level of spending. Level spending. And then if I look at this, I can see the model fitness, F statistics significant, and also the beta coefficient is also significant, meaning that it is significant predictor. The significant level, you can look at the T values, T statistic, or the sig level, the P values now here. So they are all less than, I mean P value less than 0.001. At 99 level of confidence, we can see that it's significant. Then the other one is, we can look at the other key tests. The other key condition, I know there are 4, but even if you consider the other three, the third one, once you the other third one, Share, is the data being seen?
I'm not seeing the outputs.
Yes, please.
The data is being seen. It's the output we are not seeing.
Oh, sorry. So here I can now look at the third one, which is actually key. I can go to linear. This time, the third one, I know that, whereas there are 4, but the third one is the key. I can now look at the dependent variable, which is the level satisfaction, and then I introduce the independent variable, which is the income. Now from there, I now need to do it at a hierarchical level. So I need to look at R change. When I do it at hierarchical level, it means that I'm just looking at what happens to income in the presence of the mediator. In the presence of mediator. So when I enter to the mediator, what happens? I think now let me try to put the outputs. Chair, do you see the outputs?
Yes. Outputs are
Okay.
still.
Thank you. When we included the mediator and we looked at the income in the presence of the mediator, where I'm looking at the other C prime, for those who are there, I don't know, for those who have joined, perhaps you may not be able to have logical or some level consistency of thought, but the earlier path diagram I showed, it was showing the C prime. The C prime is that relationship between the independent variable and the predictor variable. In this case, our independent variable, which is the income, and the level satisfaction in the presence of the mediator, whereby the mediator is the level spending. Has it changed? Look at the sig level. You can see the sig level in the presence is not significant. The beta value is 0.131, but you can see it's not significant. What does it mean? But when you again you look at the level spending when it was introduced, it became significant. Now, according to Baron and Kenneth thinking here, this is why you can now plausibly say that perhaps there was what? there was a full mediation. Since when you brought the mediator, the direct relationship actually, the significant level collapsed, meaning that is more full mediation. That is at that level, you don't conclude from there using these results. But you can see now that even when you conclude at that level, you are not sure whether what was the value of indirect effect, what was the value of the direct effect. The only thing you can do would be to multiply those A and B, and then you get the direct effect. So you find that you are doing it actually a little bit manually to make a conclusion. But so the Zoberi now had to look at that weakness, and then was able to come up with a better model, which brings in the indirect effects and direct effects and even the total effects. Was able even to tell the level of significance for that indirect effect, the level of significance for that indirect effect by looking at the Zoberi value, the Zoberi value. So, ideally, chair and the members, this is what Baron Lekene was particularly paying attention to, as was to look at the mediation, meaning that if you use that approach, that is the procedure you'd be able to consider. Now, the next is now, if now we are to use, if we are to use the Zoberi test, what happens? If we are to use a Zoberi test, what happens? The good news that for Zoberi again, together with other colleagues, the Goodman and others, they were able to come up with some bit of Excel sheet. They're able to come up with some bit of Excel sheet, but because they are building from what Baron Lekene had already come up with, you will see that what they added was something not so big, but of course a bit significant, because they're able to tell that if there is indirect effect, perhaps you have either full mediation, partial mediation, was it significant or not significant, and what was its value. So you would tell that, which is different from the other one. So, Chair, may you confirm whether you are seeing the med graph?
Yes.
Okay, thank you very much. So, for the med graph, once you have known the procedures for the Baron and Ken, you have known how to regress those variables. Then it is important now that you can pick this med graph. It is online. You just can download it, or you can even do it online, and then you get your outputs, and then you can just put it in your text. So in other words, here we are saying that once you know your independent variable, in our case, our independent variable is the income. The mediating variable, which is again the independent, but being an outcome for the income level, is the level of spending. Then the outcome variable is the level of satisfaction. Level of satisfaction. Level of satisfaction. Now, whatever you type definitely will always be reflected. So, if you look at the correlation analysis, the values we had, I'm sure we captured them. The correlation. So for the spending and income, since I'm not going to do it simultaneously by closing and sharing, I think let me put the values that I have here. The level of spending and the level of satisfaction. The first one now here is level spending and the income, which is according to this I have here, spending and satisfaction, correlation between the level spending and satisfaction. Okay, between the income and level spending, I have 0.942. 0.942. And then for level satisfaction and level spending, level satisfaction and level spending, I have 0.826. 0.826. Then level spending and level satisfaction, level spending and level satisfaction, I have 0.791. 0.791. And the sample size, which assumed with the data assumed, in my data, the assumption was that I considered 50 observations. 50 observations. Now, remember this, these results we are getting them from the first model we had to run, the one which has correlation, zero order correlation, and then the other one which had regression. So for the regression, we shall now go to regression. But basically, this is what I have for the correlations between or among the variables. Now, if I go to regression now, for the regression, we have level of spending. The level of spending regressed on income. Level of spending regressed on income. Level of spending on income, I have the beta value and standardized to 1.129. According to what I have is 1.129. The standard error is 0.058. 0.058. Then I have also level of spending, level of satisfaction regressed on income, and also regressed on spending. So which values do we have? Again, following the other regression model, or regression results that we generated. Now it's a matter of picking now the values from the outputs, and you feed those values into this med graph. So spending and level satisfaction. Level satisfaction and spending. I have the beta value 0.818. 0.818. The standard error I have 0.008. 0.008. Then for standardized, I think I need to look at that. For standardized, let me look at the standardized. Chair, are we seeing the med graph, or it is hidden?
We're still in there.
When I type, is it okay? You can observe.
What I see is regression.
Yes.
Yeah.
Okay. So for standardized, I think let me share the outputs. The outputs. So we are saying that when you regressed the income with the level spending, we are able to get both standardized and standardized. The income levels, we got 0.1129. Then standardized was 0.942. When it came to level spending with the satisfaction, and standardized was 0.818, and standardized was 0.826. Then I think that is fine. So let's go back and fill the other med graph. The med graph here. So the beta standardized spending and level satisfaction is 0.826. 0.826. Partial correlation. Then income with standardized beta. Income and beta. So the income and beta, I might just go through it because income and beta, income with level satisfaction. Income with level satisfaction. Income and level satisfaction, we have that is 0.938 with standard error of 1.05. Standard error 1.05. So we have 0.938 0.938. The total R, total regression. Total regression means we have to look at the prediction, the contribution of all the variables in the model. All the variables in the model. And that gives us the R. R is 0.827. The R square is 0.684. 0.684. Which gives us 0.684. 0.684. Now there's something I've taken the partial correlations 0.2425, but remember when you are running a regression, you need also to select the partial correlations. Now, having got the values and you have substituted there, I think the next step is just to run the model. You run the model. Chair, can you see the model?
Yes.
Okay. So you can see that for this one, it gives a bed value of 9.052, and the p-value is also there, which is less than 5%. Then what about the indirect to total ratio is 94.2. 94.2. Remember the other one, when we used the Barnard-Ken, we found that when we introduced the mediator, the income level could not significantly predict the dependent value, which was our level satisfaction. Now, at that level, we concluded there was a full mediation because that mediator took all the kind of strength in the relationship, which would have come from direct relation between the income and the level spending. Between income and level satisfaction. Now, what does it mean? It means that actually the level spending praise is actually the conduit through which the income influences the level satisfaction. To a layman's person, it is only when, I don't want to use the word when, that looks as a condition, and when it is a condition, it ceases to be a mediator. It means we are talking about now the moderation. So the best word is to say is that when income influences the level of spending, the level of spending influences level satisfaction, meaning that the level of spending is the only way that the level of income can influence the level of satisfaction. So theoretically, it means that for us to have level of satisfaction, we must spend. We must spend. There's no any other option. We must spend if we are to have to ensure our income and we have the level of satisfaction, then we must spend. I think basically that's what I can say here. And the level of spending contributes 94.2 in the relationship between the level of income, in the relationship between the level of income and level of satisfaction. Meaning that don't take spending light. It means that we must spend. The question is that what do we spend on? Autonomous spending, disposable income. I think that is a debate now that one can take from the theoretical understanding. Chair, can I stop here now?
Okay, yeah, thank you so much for the presentation. And I believe that the discussion, I believe that from our discussion, different people could have had different observations or maybe the points of clarification. But members, join me together and appreciate Dr. Gideon for taking us through this, and we have enough time to discuss. Last week, we didn't have enough time. We just had to close in because we overshot. So I believe since even if you have some questions for the last session, you can be able to ask, or if you have comments to make. But possibly before we move to that, allow me to acknowledge some of the new colleagues who came in when we had already started. Allow me acknowledge Dr. Sonny Nyeko. You're welcome. Dr. Hassan Bashir, Dr. Goret Chiunem, and Dr. Isaac Newton Kayongo. So members in the call this morning, if you have any comment, you can be able to raise up your hand, then ask, or you patch them in the chat room, and then the presenter can be able to respond, but also their senior colleagues in the platform, and also people who are experts in this area. I know we have people like Bernard, they can support the process. So if you have any comment, you can raise up your hand and then make, or you can patch them in the chat room. But again, Dr. Gideon, I must thank you, and member states has joined together to appreciate Gideon for taking us through this. So if you have any comments, you can raise up your hand or patch them in the chat room. Yes. Yes, members. Any senior colleague who can add something? Maybe as people are trying to get what to comment. Bernard, do you have any comment, addition? Yes, you can unmute your mic. Michael, you can unmute your mic and make your comments.
Thank you so much, Prof. This is Michael Timuzigu. I thank so much Dr. Gideon. However, I want more clarification about where to use regression and correlation, because he said that the research design determines whether a researcher is going to use correlation or regression. In that, if it is longitudinal, one can use regression, and if it is longitudinal, one can look for causation, which means a correlation. That if it is longitudinal, one can correlate, and if it is cross-sectional, then one can look for the effect which attracts regression. I don't know whether I'm putting it right, but Doctor, I want clarification on that. Thank you so much.
Okay, thank you so much, Michael. Dr. Gideon, maybe you can respond to that as we wait for more comments.
Oh, okay. Thank you very much for that comment. I think I need to make it very clear that one, I emphasize that whenever you're testing for moderation and mediation, the assumption that you are looking at the path models. Path models means that you are looking at the causation, causal relationships. Not every relationship implies a causation. It means the way you interpret your results again is very, very important. I would say that all along, most of us, we test for moderation, moderating effect, the influence of X on Y when you have done a cross-sectional research design. When I come and I interview, I give you a questionnaire and I get the data at that point in time based on perception. Can I understand the influence in the relationship between the variables I'm trying to study? So in other words, I'm trying to say that we may need to rethink when do we do moderation and mediation with our research designs. There are those studies, there are those research designs that help us to understand the influence, the effect, the cause. X causes Y. If you want to know the cause of X on Y, should you do a cross-section research design? Should you do a longitudinal kind of study approach where you do panel data, where you do time series data? We use time series data. So I think this is something I've said it is food for thought. It is food for thought. I have seen over time with cross-sectional studies, we are using those hard words to imply that we have understood the causation ideally. So I think for me that's not right. If I again maybe simplify it further, if you smile I smile. Is it me who has made you smile? But we can say there is association between your smiles and my smile. Now, if I try to make a prediction and see, let me smile and see the change in your smiles. I'm now going to another level. The first one, I'm trying to look at association, which is the correlation. The second one, if I change the way I smile, and I see also the way you smile also changes, then I can try to bring in some kind of beta values now. I talk now in terms of beta values. I can now say there's some kind of marginal change in the relationship between my smile and yours. And that level, I'm particularly trying to understand the regression. Now, I know for regression, you usually use it to answer a number of things. One, you want to see the contribution. You want to see which of the variables are key predictors. And remember, for cross-sectional studies, there are words we tend to use. A change in this is associated with a change in this. We don't say a change in this leads to that. People have used longitudinal studies. The way they write, the tone they use, reflect their research designs. I don't know whether I'm trying to answer your concern. For me, that is what I was trying to emphasize. There are two things I'm mentioning. One, pay attention to research design and the tone you are going to use when you're interpreting your correlation and regression. Three, pay attention again to when do you do mediation and moderation testing, since mediation and moderation considers the path modeling, which means we are into causation. We are into causation. So, do you find that we are really at the level at which somebody who was able to come up with these models, are we really trying to become innovative, or we are okay? I think this is food for thought. It's food for thought. One time somebody can turn around to you when you have used cross-sectional research design, especially on the mediation testing, since it goes into causation, and yet you have gathered data at point in time. The other one is, I think Sylvia is saying, do we have other methods of mediation testing? Ideally, they are there. It's only today we have just looked at the one approach. The other one, we can even use other softwares now. We can be able to use the bootstrapping, using the software that considers the measurement errors, and the one that actually is so suspicious, especially when you use when you have high measurement errors. And that's when we talk about the EMOS for structural modeling, then smart pairs and other programming software. Now, the other thing I want again to emphasize, I think for us, let people understand, even if we talk about structural models, we are talking about very many regression models, very many regression equations. That's why we call it simultaneous testing or mediation. It now tests a number of simultaneous equations. I think if you remember the simultaneous equations, we used to use two unknowns. Two unknowns. Then we go to more than two unknowns, 3. Then we go to 4. We may have very many unknowns that you may want to solve the equations with very many unknowns. What do? There are those softwares that can do that, and that's when we go into those other models that tend to bring also aspects of bootstrapping. I don't know how I've attempted to answer that. Chair, you can guide me, especially on the chart, if there are some other concerns.
Yeah, there are charts by Peter and then Teresa. Yeah. Peter is saying, I pray that Dr. Gideon can also take us through my question. Thank you. And then Teresa says that thank you, Dr. Gideon, for the wonderful presentation. How do we go about this in the secondary data? And then I think then Charlie, thank you so much, Dr. Gideon, for this excellent presentation. How does this model approach differ from that of hair? Tal 20 that looks at percentage ratios. Dr. Gideon, you are there?
Yes, please.
So you could begin the one of Teresa, I think. Then Charlie.
I think, as I've mentioned, today we have just looked at 3 variables. We may need also to look at more than 3 variables. How do we test them? Using the softwares that involve structure fusion modeling, where you have very many variables and you are doing the mediation for many equations in the model. The other one is about moderation. Ideally, of course, that also requires also some also other day to look at that. Different day. We may also need to look at mediated modulation. Now, the current theory is actually we're extending further, that we may not only stop at mediation or modulation. For modulation, I know it's like a condition. There are certain questions you could pose when you're asking, especially to find whether mediation exists. For example, I can pose a question: under what conditions does income influence level of satisfaction? Under what condition? I'm actually going into the moderation. So if you have a question of that nature, you have tried to write your background and you pose a question: and what condition does income influence the level of satisfaction? There you are going into the moderation. So ideally, I think according to what I think we are planning, we may also look at that if time allows for the next sessions. Chair, there's another question you raised, although I have not noted it. Maybe let me look at the chat. How do you handle the second? I think for 2 by 2, once you have tested those assumptions. You have tested for those assumptions, depending on whether, again, that is also something you have to pay attention. If you are dealing with the panel data, you are dealing with time series data, then I think you need also to know the theory behind the analysis there. Once the assumptions are fulfilled, then it doesn't stop you from using these past models. It has no problem. For example, actually, when you look at the data that I have used today, I have generated it on assumption of longitudinal. It is data which has been observed over time. Although we did not go through the rigorous tests of those diagnostic, I think that if you have to go there, it would mean again looking at it separately, in-depth understanding of each of the tests you have to handle. Now, this also reminds me that the choice of software to use again may be determined by the analyst again as well, because there are different softwares that answer the same things. Softwares answer the same things. So if you are used to Starter, which uses commands, still you can run the same data set and you get the same kind of results as you use the SPSS. So I think this is also about the choice. Other people are used to other programming, other software programming. If you are used to programming, still you can still run your mediation and moderation. I think the science behind analysis also goes in line to somebody's interest. At the same time, understanding the conditions under which each of the statistical package can be relevant to answer those questions or research questions you have.
Okay, let me invite Dorcas to raise the hand.
Thank you, Chair. Good morning, everyone. I want to thank Dr. Gideon for the presentation. When you look in the chat, Mr. Collins was trying to ask a question on how does the Sobel's approach differ from that of Hare et al. 2017 that looks at percentage ratios? I just want to add my voice on that by telling him that when you read Hare et al. 2017, he actually tries to address the weaknesses in the Sobel's test. And when you read further, he will tell you that one of the weaknesses in Sobel's test is that it yields a lower statistical power. So this means that he further recommends using bootstrapping that yields higher levels of statistical power compared to Sobel's test. So I want to think that maybe as you read, you didn't read properly, or you didn't try to understand what he was saying. And then with this issue of percentages, the percentages you're talking about are called, that is what we call the variance, the VAF, variance accounted for. And this variance accounted for was clearly articulated by Hare et al. 2014. Now, when you come to Hare et al. 2017, he does not give us the VAP. He does not give us that threshold. And that threshold, if you read Hare et al. 2014, he'll tell you that when you calculate VAP, that is indirect effect over total effect, and it's above 80%, then there is full mediation. If it lies between 80% to 20%, we consider that as being partial mediation. If it is less than 20%, then it means that there is no mediation at all. So what I wanted to maybe tell Mr. Karenzi is that for Hare et al., he actually brings out the advantages of bootstrapping when you're testing for mediation and not Sobel's tests. For the matter of Sobel's test, he brings out the weaknesses of Sobel's test vis-a-vis bootstrapping. Thank you very much.
Dorcas, thank you so much. Thank you so much for that submission. Is there any other comment? It looks like we're almost coming to the end of our session. And I want again to thank Gideon, unless there's any critical comment I could give. Senior colleagues, any comment before we close? Okay, I think let us come to the close of this session. But before we completely close, there is a question here by Julius. Is he asking you that, he asking the presenter and maybe any other colleague, how do you determine the level of significance or no significance when handling correlation or regression in calculation? Dr. Gideon, could you respond that as Professor Sam Adaramola will be able to help us to close the session. So Dr. Gideon, you could make a comment on that question by Julius. Then we shall have Professor Sam close. So Professor Sam, let us first have Gideon respond to that comment, and then we can go ahead and close. Yes, Gideon.
Okay, thank you very much. I know that maybe the science behind the level of significance would be another debate. I know if you go into statistical inference, our assumption that at times you don't need to study the whole population. You can take a sample and you inform that. But of course, there is also a theory behind that, the center limit theorem, that you keep increasing the sample size until you find that perhaps the level of precision can come in. Now, the level of precision again vary from where you're coming from. There are those who believe that if the level of confidence is 99, especially you are safer, meaning that if you allow just 1%, the level of precision there, at times you know that there's that level of confidence in your results. The confidence again, what does the confidence mean there as you look at the significance? It means that when you can repeat the same kind of study with that same sample size, more or less the same size, you are likely to depict some similar results. In other words, your model can depict the reality out there. I think that is what I can say. So you can allow the 1% level of significance, you can allow 5% level of significance. Even those people from economics, especially where they know they are dealing with those variables that have been known. Even when you have 90%, at times you say, yeah, 10% is allowable, and therefore you can be able to accept your results to be able to be generalized in that perspective. So I think it may need another debate there, but that's what I can explain now, Chair.
Okay, thank you. Let us have the session now closed by Professor Sam Adaramola from Norway. And also on this note, I want to acknowledge most of the people who have been able to log in. Professor Sam, please.
Thank you, Chair, for allowing me to close this session. And thank you very much, Dr. Gideon, for the good lecture that you gave us this morning. And for our students, I think one of the things I always say is that when we listen to this kind of lectures, let's go back and let's go and get some data and practice what we have learned tonight or this morning, so that next time when we come back, we could also ask some more detailed questions that will be based on our analysis or some of the things that we practice. So that being said, I appreciate every members, both students and the seniors within this platform this morning, and people within Uganda and outside Uganda for joining. And I know it's not easy to wake up very early in the morning and be part of this particular activities, but I know that the effort of Professor Ontai and the other team like Professor Okoshe, they actually helping a lot of us, a lot of students to learn almost like a free tuition that is benefiting almost everybody. When I check at the peak today, we almost about 90 people, around 18 now, 90 people here, which means that is something that people see benefit. So please let's continue to be part of this platform. And most importantly, when we learn new things, let's go back and try to put them in practice, not just learn and forget. So please, that's what I will say. And thank you again, Dr. Gideon, for a wonderful presentation. It's more like a teaching, it's more like in a classroom. It's not even like a presentation at all. And thank you very much. So that's what I have to say. And I thank for everybody that joined again. And I wish everybody a beautiful rest of Sunday. And thank you and goodbye. Back to you, Chair.
Okay, thank you. I know people wanted to say more things, but I think this session has been closed. Gideon, you can again share with us the presentation on the platform. So members, let us humble ourselves and pray. Father, in the name of Jesus, we want to thank you so much for this moment. We thank you so much because we have been able to congregate in this platform to share knowledge and insights and help us to understand. And also we thank you for all the people who have facilitated this platform. More specifically, we want to thank you for Dr. Gideon and our mentor and all the senior colleagues and all the students. Father, even as we start this week, we pray that you keep on guiding us. Pray all this through Christ our Lord. Amen.
Amen.
Yeah.
Thank you, professors and our seniors. We are very grateful. Thank you.
Thank you.
Amina.
Goodbye.
Bye for
Bye.
now.
Good day.
Bye for
Bye.
now. Good day. Good weekend.